I wanted to start out with what might seem already rather disrespectful slide, remedial philosophy for geeks. Now, we've heard of philosophy for dummies and for idiots. There's all of these kind of titles. Remedial, that even sounds like more of a put down. Plus, it's an oxymoron. I mean, how can philosophy, which is such an esoteric subject, be remedial? It's almost like, remedial brain surgery. It doesn't make a whole lot of sense off the top. But I'm going to give some explanation for why I'm using this, and I hope to use the theme of the title as a way to get into the subject, what we're talking about. What are we talking about? Uh, Lately, I've been taking Buckminster Fuller's philosophy and repackaging it as what I call Martian math. Now, I have a lot of reasons for doing that. Partly just play. I find it has a lot going for it, so let me get to that in due time. However, let me talk a minute about Buckminster Fuller. He was a writer, a thinker, and we can go on with a long list of things. But you can go on YouTube. Presumably, you're on YouTube, and just pull up some of his videos. He has a lot on tape. So he lived throughout the 1900s until about 1983, and he was very, very popular. He wrote a lot of best-selling books and so on. And I would say he's a philosopher for sure. And yet, if you go to a contemporary university, I don't think you're going to find much more than I've been able to find so far. I'm recording this in 2015, just before Halloween. It's October 30th. So in that time, we're talking, 50 years later, there's still not a whole lot of information. Now let's look, and contrast somebody like Martin Heidegger. He's already been dismissed and then rehabilitated. I mean, a lot of these contemporaries of Fuller's had all kinds of press comparatively in the philosophy department. Now, why do I think this is philosophy? It looks a lot like something else, maybe engineering. And that's the problem right there. My explanation, part of the explanation, I'm going to have two main reasons as to why Buckminster Fuller, never really generated a whole lot of interest after he died. Some. No, I'm not. Among artists, especially. Now we're talking. Let me back up. Let me say I think no other philosopher has had as much attention in some dimensions. He's had museum exhibits in art museums, New York Museum of Modern Art, Chicago, blah blah. Uh, Philosophers don't get that kind of treatment usually, so he must have been an artist. But then the artists will say, no, he was more of an architect. And that's the problem number one as to why we don't find him either in philosophy or literature, is that you hand his book Synergetics to somebody and they're gonna flip through it a little bit and they're gonna say, no, this is not philosophy. It's too technical. If it means anything, it sounds too, phenomenologically, it's not philosophy because it uses sort of the wrong set of terms. It doesn't try to insert itself into the conversation, but it does. He's not writing a complete nonsense, I would argue. Plus, he has done his homework and cites a number of other thinkers. You can't just expect to be taken seriously if you've done no homework. But I would argue that's not the reason that his material has been ignored. It's more, let's see, here's a nice one. It's more that people haven't known how to deal with synergetics, where to put it. Now, I've got it right connected to philosophical literature, but then I'm immediately branching to Martian math, which I'm connecting to what I call new math, which is kind of a pun. If you grew up in the 60s as I did. I'm already in my 50s. I was taught something called New Math, N-E-W, New Math. And so here we have New Math, GNU. As you know, GNU stands for New is not Unix. It's a recursive algorithm. And now you can see why this is for geeks, because I'm talking the geek language now. Out of New came the tools that were needed for Linus Torvalds and collaborators all over the world to put together an operating system that, unlike Unix, was not copy protected in the same way. It's protected against abuse. Um, we can go into licenses and so forth, but let's not. Uh, Python is a language that I use to help get across some of this Buckminster Fuller stuff. So when you're studying this stuff, you're going to maybe want to use a computer language. Okay, so that already sounds like maybe it's not philosophy, maybe it's engineering. Okay, here's a picture of Fuller's synergetics. And synergetics 2, that's where the index is. You're wondering, where's the index? It's in the second volume. So you open this book, and if you're in the philosophy department, you're going to see there's no mention of Derrida, so it can't be continental philosophy, and there's no mention of Wittgenstein or A.J. Ayer. Where's is it Vienna Circle in derivation? I mean, where do you categorize it? No, it's just not part of our language. No, it's not. It's not in our tradition, I would say, is what a academic philosopher would say. And they pass it on to the engineers, who pass it on to the physicists, who pass it on to the mathematicians, and at no point does it ever settle down. It's the hot potato, a hot potato that nobody wants to take on. But is it completely worthless, therefore? See, I would argue not. Um, let's see, did I just get lost here? Buckminster Fullerene was not idly named for Buckminster Fuller. Nor is all the stuff that he's famous for, like the domes and all the art and stuff like that, nor is that not connected to his synergetics. In other words, from his philosophy derives all of this other stuff that he did achieve great fame for. Now, when you think of Kant or Heidegger, what were their great inventions? How did their philosophy translate into praxis? We're always talking about theory versus practice, and philosophy. Where does the rubber hit the road? And I would say with Bucky stuff, it really does hit the road clearly. So what's the other reason? I was going to give two reasons why his stuff is not really looked at. One was the hot potato nature of it, that it's written in a language that no one wants to own or recognize as theirs. So, it doesn't fit into any academic pigeonhole or department. And number two, well, it's similar. It's similar to number one. Fuller himself was rather polemical, meaning he took issue with, you could say, attacked. He really built a worldview around the idea that academia had become too over specialized. In fact, that was a chief threat to human survival, maybe number one threat. Not global warming, not this, not that, but the fact that each one of us has been trained to think in a very narrow box. And the more intelligent we are, or the more we commit to study, the more specialized we get, not the more comprehensive. Comprehensivism, big picture, seeing the whole, this is actively discouraged in academics because you want your PhD to be in something very, very, very zoomed in. So with all your people being super zoomed in and very few people wandering from one discipline to another, you lose the big picture completely. And he formed this into a very coherent critique that he leveled at academia, basically saying, all you people are doing it wrong, you're being too specialized. And so the natural reaction when you're being attacked, even if it's just by one little guy, is, rally circle the wagons and defend against that, Or you can come back with something like, okay, you're right, we're over specialized, but let's compromise. We should all specialize in at least two separate disciplines, like never just one, something of that nature. That was Donald Knuth sort of thought that, and he's the father of computer science, you could say, or one of them, and he went and did a sort of second specialty in theology, so he walked his talk in that respect. So, enough about why Fuller is not studied. Gave two reasons. His language is not recognizably that of contemporary philosophy, and according to his own theories, people were just too specialized at this point to be able to get outside their box. Now, what is core to synergetics? I've been browsing as I've talked, looking at all these pictures of Martian math, looking for a good entry point. I think in a flat world where we're just looking down, you see a triangle here. Think of a civilization, Martian if you will, that has a different model of multiplying. When I want to multiply 2 times 2, I put these two rods at 60 degrees to each other. We can talk if other angles would work. Normally we put them at 90 degrees. Normally we draw a square at this point. We say 2 times 2 is 4, and we draw ourselves a square right away without much thought. And if we're well trained in school, we say 2 squared, 3 squared, 4 squared. This is exactly where Fuller departs from, you could say, Western mathematics or Greek civilization or whatever you want to say. And he goes to a tetrahedron as his model of three third powering. So instead of saying 2 cubed, you could say 2 tetrahedron. And the thing is, it's logical in the sense of consistent. You can do it this way. You can use triangles on a flat surface and a tetrahedron growing and shrinking as your model of third powering without inconsistencies. And what are the benefits? The benefits are you get a whole number of volumes for very common shapes. Let's see. This was a Google Images search, and Martian math is what I searched on, and I got a lot of interesting imagery, but some of it's mine. Um, these volumes, I remember doing these many times in these exact colors. I'm sure this is my graphic. Um, the volume of the tetrahedron becomes a unit. The octahedron with the same edges has volume 4. The cube with the same diagonal, base diagonal, has volume 3. And the space-filling rhombic dodecahedron, that has a volume of 6. Now, it sounds like I'm talking about math or geometry, not philosophy. Again, in the old days, philosophy was all about polyhedrons. I mean, why are they called the Platonic Polyhedrons? And Plato, he's the big philosopher that we all know. So Fuller is right in the ballpark of what we used to call philosophy in talking about polyhedrons all the time. If he had been born and written anything close to what he wrote, say in the time of Neoplatonism, it would have been no question that this was philosophy. It looked like other people's philosophy in terms of being all over this geometry stuff. What we look at today as philosophy has departed greatly from geometry, and therefore they're going to say, "Oh well, this isn't philosophy anymore because that's not how we do it anymore." But this is a very visualizable um, way of approaching thinking. I'll just mention now that the subtitle of Synergetics is Explorations in the Geometry of Thinking. So if that doesn't sound like a philosophical work, I don't know what does. So yeah, you come up with a different model of second powering, a different model of third powering, and then comes a question of how do you relate our current way of doing volume with his? Is there something as simple as a conversion constant, something like a currency conversion, where you can go between the two? As a matter of fact, yes. It becomes the square root of 9/8, you could say. Is the conversion constant? That depends on a convention where we say the normal Earthian way of doing a unit cube, we're going to say is all edges are. And then we're going to just say, as a definitional thing, that the Martian tetrahedron has edges D. D being 2R. D for diameter, R for radius. So we're just going to define all this like this, and then, okay, are these volumes the same or not? They're not. Which is bigger? Actually, the cube has a slightly bigger volume in this picture, but which one is unit? Now, it's no question in the Earth world, in the Earth math, we've always wanted the cube to be our unit, but in synergetics, we have a logical and just as acceptable way of showing third powering, all based on the tetrahedron, and so there's your relationship. That's where we get our conversion constant. Then once we're in tetrahedron world, we want to break it up into smaller modules. We do the same with the octahedron. We build things. All of a sudden, we're in build mode. We're like in a classroom, third grade, second grade, pouring beans from one polyhedron to another. All kinds of very simple, easy things. So why, again, wouldn't this be brought into the school systems at all? Isn't there literature here? Fuller's great aunt, Margaret Fuller, was one of the founders of, or she was an editor of Dial magazine. You can read about Dial and say Wikipedia. Later, went on under other editors to sort of take a different approach. But in her day, when she was editor, she published like Emerson, Thoreau, and so she gets the title of like the first, well, because women didn't get much recognition in those days. She wasn't only a transcendentalist, she was a female transcendentalist, and like Thoreau, like Emerson. That was Fuller's great aunt, and when he was at Harvard, he took time off to make sure he went and looked at her stuff as well. He didn't just stick to what they told him to read. So Fuller, he was kind of a transcendentalist, and that's another reason why he maybe doesn't get into academia a lot. I put the CIA here. He was into calling it capitalism's invisible army. He wrote a lot about world history and politics, and especially Cold War stuff. He lived through the Cold War. He lived through World War One. He lived through World War Two. He was a player, so all this stuff made a big impact on him and how he approached the world. And he needed to fit a puzzle together like we all do. So if you read Grunch of Giants, a sequel to Critical Path, one of his last books, quite accessible, quite short, quite easy to read, it's got the CIA in there all the time. Plus, his close collaborator on Synergetics, the 2-volume work, is a gentleman by the name of Ed Applewhite, who passed away later than Fuller. And I actually knew him. I knew him a lot better than Fuller. I won't get into my biography in this video, but I met a lot of these people who worked with Bucky, and I can see where, now that I'm in my 50s looking back, just the fact that he would be enmeshed in history and politics the way he was made him kind of a hot potato just for that reason, right? Even though the book then is also written in a language that's hard to understand. Again, I'm talking about Synergetics and Synergetics 2. Now, Critical Path, let me be honest there, that has some rather speculative material in the beginning about, how people came to planet Earth and all this stuff. It's very interesting, but you can only read it as science fiction. He's like projecting way, 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 way into the future when maybe we have technology that lets us teleport to other planets. Maybe we're going to get there someday. He thought so, like in Star Trek, or somehow you're going to be able to encode information and beam it to other planets. And if you project into the far, far future about what we might be able to do someday, and then if your second belief is that the universe has always been intelligent, like he's not a Big Bang guy, there's another reason he's probably not embraced. But then we've had a lot of not Big Bang guys. Anyway, he sees the universe as always intelligent, and so anything we're going to be able to do as humans in the far distant future has already been done. So if we get to go to other planets, then you know. I just wanted to warn you, it doesn't stay that way. The first speculative prehistory is it's out of this world, and then it gets more believable as you go along. And then Grunch of Giants, the sequel, is highly believable. It's like he gets more and more believable and more of a hot potato, I would think. He invented the geodesic dome. Now we can say he it's part of a zeitgeist where geodesic domes were up for discovery, as were a lot of the things he was into. Alexander Graham Bell was into the same scaffolding that Fuller was into. Great minds think alike and all that. It's like you want to worry if you're not thinking at all like your contemporaries, and he actually was. He was thinking about sphere packing a lot of his life. Anyway, his geodesic dome, you didn't have to put all the furniture up against the wall. People criticize them because how's your refrigerator going to fit against a curved wall? The idea is the dome is permeable to sunlight and is a giant greenhouse like the Climatron in St. Louis, and you build your house inside, and it can be rectilinear if you feel better that way. But it can be flimsier too, in terms of not so expensive, because all the environment control is taken over by the dome. The dome protects you, and then inside it's more like theater props. You can change your house more because you can reconfigure it. Very great ideas there that haven't been fully exploited by any means. I'd say that's a smart house compared to any house we have now. Smarter house. Okay, so that gives you a good introduction to, you see, this is showing how contemporaries were thinking the same way as Fuller. This is from Linus Pauling's collection at Oregon State. Same closest packed spheres, that's all we talk about in chemistry. I'm exaggerating. So in Martian math, we have the Earthians and the Martians coming together to build a dam together. And I've talked about that in other videos. It's a way to get kind of a comic book treatment of synergetics, and cartoons could flow from that. I have optimism that we will at some point live up to or take advantage of our heritage. I mean, there's a lot of good learning to be had here. So even though there's been a long delay as far as teaching this stuff, I'm still thinking it's not too late. Maybe. So good to talk with you, and I'll be doing more videos, of course. But I did want to explain why I call this remedial philosophy. It's because we should have been doing this for a long time, and at least I think geek culture, with open source and so forth, is in a good position to pick this up and take it forward, with or without help from the university culture. I think with help, but it's been taking a while. All right. Thank you very much. Talk to you soon.